Welcome back to Math 104. The next thing we need to understand is how to build up new, more complicated events out of simpler ones using certain operations on sets. These operations will be union, intersection, and complement. To put it briefly, union will roughly translate the word or, intersection will roughly translate the word and complement will roughly translate the word not. But we will need to be careful about how we use these operations to make sure that we are correctly translating the English description of an event into the correct set notation. The union of two events E and F is the event denoted by this symbol, which is read E union F, which consists of those outcomes which are in E, or in F, or in both. What is E union F? It is the result of taking the outcomes in E, the outcomes in F, and merging them into a single set. If an outcome happens to appear in both E and F, it is listed only once when we write out E union F as a set of outcomes. Here's an example for the experiment of observing birth order in a randomly selected family with 3 children. Let's define some events to work with. Some of these we've thought about already. E0, the event that there are exactly 0 girls. E1, the event that there is exactly 1 girl. E2, that there are exactly 2 girls. E3, that there are exactly 3 girls. Assuming that the outcomes are equally likely, let's find the probability of E2 union E3 and describe the event in words. Let's write out E2 union E3 as a set of outcomes. What does it take for an outcome to become a member of this club? Well, there are 2 ways to become a member of this club. It can be a member of E2 and thereby get into the club. It can be a member of E3 and get into the club. Or it can be a member of both and get into the club. We have BGG and GBG and GGB. Those are all the outcomes in E2, which are therefore in the union. What about E3? E3 contains only GGG. We've taken all of E2 together with all of E3 and then just merged them into one list. Since we're assuming that the outcomes are equally likely, and there are 8 ways that the experiment could possibly turn out, the probability of this event equals 4/8, or 1/2, or 0.5. To describe this event in words, we could say, there are at least 2 girls, or there is more than 1 girl, or there are 2 or 3 girls. All of these are perfectly correct. But the point I really want to make here is that you don't need to say exactly 2 or exactly 3 or both, since the or both is superfluous. A family cannot have exactly 2 and also exactly 3, so it's enough to say 2 or 3. In general, when you talk about unions, you need to think about the or both, but in this particular example, E2 and E3 had nothing in common, and therefore the or both played no role. Some other more interesting events we can think about are F, the first child is a boy, and H, the middle child is a girl. What we're about to do next is really important. Use a Venn diagram to represent F, H, and F union H, and find the outcomes in each of these events. First of all, what is a Venn diagram? A Venn diagram is a very useful way to represent sets and their relation to one another visually. It displays 2 overlapping circles where this entire circle is labeled by F and the other entire circle is labeled by H. Implicitly, the entire rectangle and everything inside it represents the full sample space. In this course, we will always draw these 2 circles as overlapping circles, even if it turns out that there are no outcomes in common between the 2 events. So we always draw like this when there are 2 events that we're studying. In this diagram, there are 4 basic regions, which means regions that are not further subdivided. This right here is the basic region that is inside the F circle but outside the H circle. This basic region is inside the F circle and inside the H circle. This region is inside the H circle but outside the F circle. We've written the letter H here. The letter H really refers to both of these basic regions. We've written the letter F here, but it really refers to both of these 2 basic regions. Finally, there is a 4th basic region we should not forget, and that is on the outside here. This basic region is outside the F circle and also outside the H circle. Now let's remember what these events are. F is the event that the first child is a boy. That corresponds to words that begin with B. And H is the event that the middle child is a girl. Inside H, the outcomes are represented as words that have G in the middle. Now we can go through outcome by outcome and write each outcome in the basic region to which it belongs. In this region in the middle, which is inside the F circle and inside the H circle, we can write the outcomes in the event that the first child is a boy and the middle child is a girl. There are two such outcomes, BGB and BGG. These outcomes live inside the event F. They also live inside the event H. This region is inside the F circle but outside the H circle. So here we can write outcomes where the first child is a boy, but the second child is not a girl. We are outside the H circle. We've got BBB and BBG as the only outcomes that fit these two descriptions, inside the event F and outside the event H. Over here in this basic region on the right, we can write the events that are not in F, that means the first child is not a boy, but in the event H, which means the second child is a girl. The only possibilities there are GGB and GGG. Finally, we must not forget this outside basic region, which represents the event that F doesn't happen and neither does H, meaning that the first child is not a boy and the second child is not a girl. The only possibilities are GBB and GBG. Behold! Every one of the 8 possible outcomes of this experiment has been written somewhere in the Venn diagram. Each one lives in one and only one specific basic region. All of this is another way to think about listing and representing the sample space of an experiment. But here it is organized around 2 specific events. We happen to be working with the events F and H, but we could do exactly the same analysis with the same experiment and a different 2 events. Now in this example, it just so happened that we ended up with the same number of outcomes in each basic region, but that was by accident. That was just how this particular example happened to work out. In general, there is no reason why the outcomes would necessarily be spread out equally among basic regions. In fact, usually, there will be different numbers of outcomes in different basic regions, as we will see. Now, we didn't have to work out the Venn diagram just to be able to write out the outcomes in F, and to write out the outcomes in H, and to write out the outcomes in F union H. This collection of these 3 basic regions constitutes F union H. But having done the work for the diagram, it does make it quite easy to write down these events as sets of outcomes. So F equals BBB, BBG, BGB, BGG, H equals BGB, BGG, GGB, and GGG, and then F union H equals BBB, BBG, BGB, BGG, GGB, and GGG. When we look at these events written out, we see how F union H is the result of taking F, merging it with H, and making sure to list each outcome only once. So BGG appears in both F and H. It appears only once when we write out the outcomes in F union H. We can describe the event F union H as F occurs, or H occurs, or they both occur. Notice how or is an inclusive notion. It collects up more outcomes. There must be at least as many outcomes in F union H as there are in F alone or in H alone. Before going on to the next video, consider the events F, the first child is a boy, and L, there is at least one girl in this same experiment of selecting a family with 3 children and observing the birth order. So here's what you should do before going on to the next video. Draw a Venn diagram for F and L and label it with all the outcomes of the experiment in the same way that we've just done. So write each outcome into the basic region where it belongs. And assuming that all the outcomes are equally likely, find the probability of L and of F union L.